So good afternoon, everyone. I would like to welcome you to this PhD defense of Justin Lichter. He was the first student that I felt that there's a new generation coming in the lab. So he's really the refreshing person that led to a generation change. It's fair to say that this project would have not worked out without Justin. He had a great hands with the animals, with the experiments, getting the cell isolation here through. These were things that he was responsible, and he really filled out this task. Without further introduction, we look forward to your defense.
Well, thank you, Frank. That was very kind of you to say. Welcome, everybody, to my PhD dissertation. I'm going to tell you today about the story of what I've been doing for the last 5.5 years. The focus of this work has been on microstructural remodeling of ventricular cardiomyocytes in disease and their restoration after therapy. I know it sounds like a lot, but I'm going to walk you all through it, and hopefully at the end of this, we'll have left here having learned something new. Now, when I first came to Utah, as Frank stated, I was hired onto a grant to develop this animal model of a specific form of heart failure and then use this model to investigate specific structural remodeling and functional remodeling that occurs. According to the American Heart Association, there are over 5 million Americans currently living with moderate to severe symptoms of heart failure. And even with treatment, these patients have an annual mortality rate of upwards of 60%. So clearly, we need to do something to improve our treatments of these diseases. Now, when the heart experiences an increased demand, the cells of the heart actually grow and become enlarged, and this results in a state known as hypertrophy. Over time, if left untreated, this disease actually can further remodel and become even worsened and result in cardiac dilation. The model that I was trying to develop actually looks at a specific form of heart failure in which this remodeling process has gone severely wrong. The final conclusions of this talk, I'd like to say that together this work contributes a significant advancement of knowledge on the subcellular remodeling that occurs during DHF and CRT. I showed that there are significant structural changes in the sarcomeric cytoskeleton. I showed structural heterogeneities in the transverse tubular system as well as RYR expression, and how these structural heterogeneities result in heterogeneities in calcium handling as well as actual contraction of the cells. Furthermore, I explored how well CRT is able to reverse this remodeling. And then I also developed a novel method of obtaining this biomechanical insight into contracting cardiomyocytes that I believe will lead to better understanding of how these cells react to physical stimuli, as well as help develop more robust and accurate computational models. With that, I'd like to thank you all for being here and sticking with me through all this. I hope you enjoyed it. And with that, I'll take any questions.